solving system of linear programming problems. I said we have two approaches to this. We have the direct approach, under which we have the matrix inversion, the Cramer's rule, Gauss elimination method, Gauss-Jordan method, and we have the Cholesky method. So now we'll be solving the matrix inversion method. Remember, under the indirect approach as well, we have the Gauss-Jacobi and the Gauss-Seidel. So today we'll be solving the matrix inversion method. It's a very simple part of this course, so just stay with me. Okay. Let's take this as our example. We have 2x plus 3x, 2x1 plus 3x2 minus x3 equals to 4. 3x1 plus 2x2 plus x3 equals 5, and then x1 plus 3x2 plus 2x3 equals 6. Let's say this is our example. Of course, your question will always be of this format: ax equals to b. So now, if first thing we are going to do is to convert to get the matrix out of these particular equations. The coefficient, our a standing for the matrix, will be aij, all the elements of a in this equation. I mean all of your coefficients, such that a will be equal to 2 row by row, 3 and minus 1, 3, 2 and 1, and then 1, 3 and 2. So this is A. You've been able to bring out your matrix out of the equations. And the next thing we'll do is look at this. Remember, ax equals to b. How is that? A times x plus a times x plus a times x. In a way, ax plus ax plus ax equals to b. Your b is the solution that you have. So ax equals to b. So if I'm to get x from this, I will say x equals to b over a, right? And from your primary school, you know this is x equals b times 1 over a, right? And you can say 1 over a equals, and we can still say b times a raised to by minus 1, and that is a inverse times b, meaning your x is equals to a inverse times b. So remember, a is a matrix, so all you have to do is to calculate the inverse of this matrix, multiply it by your solution, and that will give you your x. So let's do that now, and you see. So a equals 2 3 minus 1 3 2 1 1 3 2. A inverse will be equal to, there's a formula to calculate your A inverse of a matrix. That's the cofactor of A transpose divided by the determinant of A. So the first thing you do, let's get the determinant of A first. Let's get the cofactor of A. Cofactor of A will be equal to, you draw a very big matrix like this, kind of big, and then to get the cofactor of 2, these two, you come this way, and then you close this row, close this column, and you have this left. So you have 2 1 3 2. You put plus here, and then here as well. To get the cofactor of 3, You close this column, close this row, then you have 3 1 1 2, 3 1 1 2, and then for this, for -1 you have the plus. So you close this column, you close this row, you have 3 2 1 3. So 3 2 1 3. So for us to get the value of this 3, you do the same. Here this is plus, so this will be minus. So you have, if you close this column and you close this row, you have 3 minus 1, 3 minus 1, and 3 2, 3 2. So for us to get the value of these two, the cofactor of these two rather, you close this column as well, close this row, this column and this row, so you have this and this. You have 2 and -1 and 1 and 2. You close this and you close this, so you have this and this and this and this. So for us to get the cofactor of 1, this will be plus, this will be minus. For us to get out of 1, you close this column, close this row, so you have 2 3 1 3. And for us to get the cofactor of this one, so this will be plus again, so you have 3 and -1, and then also 2 and 1. This will be minus. Close this, you have 2 and -1, and you have, what else, 3 and 1. So you can pause the video and do the last one yourself, just to check it out. But I'll continue to plus. If you close this, you have 2 and 3, and then you have 3 and 2. Okay, you're almost there. So we are close to getting our solution. So let's get our cofactors, let's get the values from this matrix. So pardon me. So from the matrix that you have, you can always check your matrix if you write it out. You have okay, so now let's get the cofactor of our A, just as we've converted to a matrix. So watch out, cofactor of A will be equal to a matrix. So you go as, from your left side, 2 times 2, that's 4, minus 1 times 3. You keep the plus on it. 3 times 2, that's 6, minus 1 times 1, that's 1. Keep the minus. 3 times 3, 9, minus 2 times 1, 2. You keep the plus. And for the next one, you do 3 times 2, 6, minus 3 times -1, that's -3. You keep the minus sign on it. 2 times 2, 4, minus 1 times 1, that's -1. You keep the plus sign on it. 2 times 3, 6, minus 3 times 1, 3. You keep the minus sign on it. And for this, you have 3 times 1, 3, minus 1 times 2, that's -2. You keep the plus sign on it. And for this, you have 2 times 1, 2, minus 3 times -1, that's -3. You keep the minus sign on it. And for this, 2 times 2, you have 4, minus 3 times 3, 9. So we'll close this. These are matrix. So the cofactor of A will be equal to 4 minus 3, that's 1, 1 times plus, so that's the plus 1. 6 minus 1, that's 5, times this minus, so this is -5. 9 minus 2, 7, times plus, so this remains 7. 6 minus minus 3, that's 6 plus 3, that's 9. 9 times minus, that's minus 9. 4 minus minus 1, that's 4 plus 1, that's 5. Times the plus, you have 5. 6 minus 3, that's 3. Times this minus, you have minus 3. 3 minus minus 2, that's 3 plus 2, 5. 5 times plus, that's 5. 2 minus minus 3, that's plus 5. And multiply by this minus, so you have minus 5. 4, oh, there's a plus here. 4 minus 9, that is minus 5 times this plus. This will still be minus 5. Okay, so these are the values of your cofactor. This is the cofactor of A. Now let's take the transpose. Remember the formula for A inverse is cofactor of A transpose divided by determinant of A. So this is the cofactor of A. Taking the transpose means you make the row the column, and you make each row column, this row another column, and this row another column. So it means your cofactor of A transpose is equals to 1 minus 5 and 7, and here you have minus 9, 5 and minus 3, and there you have 5, minus 5 and minus 5. So okay, successfully we've gotten our cofactor of A transpose. Now the next thing is to get the determinant of A. Determinant of A. From your cofactors, from your original cofactor of A, you can easily get your determinant. How do I do that? Watch out. From your matrix A itself, from this matrix A itself, so you just do 2 and this 2 and this 1 plus 3 times this plus this times this. This will give you the determinant of this matrix, such that our determinant will be 2 times 1 plus 3 times minus 5 plus minus 1 times 7. Remember, your A times your cofactor of A, that is 2 times 1, 3 times minus 5 and minus 1 times 7. So your determinant of A will be equals to 2 minus 15 minus 7. So determinant of A will be equals to 2 minus 22, meaning your determinant is minus 20. So the determinant of this A equals minus 20. Okay, we're almost there. So you are just few steps to your solution. Now we've gotten our A inverse, we've gotten our cofactor of A, and we've also gotten our determinant of A. Now let's get our A inverse. Remember, A inverse is cofactor of A transpose divided by determinant, meaning take this, our cofactor, 1 minus 9, 5, 5, 5, oh sorry, minus 5, 5, and minus 5, 7, minus 3, and minus 5. And you multiply by 1 over your determinant. So let's just do this. It means my A inverse will be equal to 1 divided by minus 20. Each of the elements in this set, each of the elements in this cofactor. So you have minus 9 in the matrix rather, divided by minus 20, 5 divided by minus 20, and this one minus 5 divided by minus 20, 5 divided by minus 20. Each of the elements divided by your determinant. Minus 5 divided by minus 20, 7 divided by minus 20, minus 3 divided by minus 20, minus 5 divided by minus 20. Okay, so your A inverse will be equal to minus 1 over 20 still. This will be 9 over 20. This will be minus 1 over 4. This will be 1 over 4. This will be minus 1 over 4. And this will be 1 over 4. This will be minus 7 over 20. Oh, sorry for that. This will be minus 7 over 20 just from here. And this will be 3 over 20. This will be 1 over 4. Okay, good news. We've calculated our A inverse. Okay, remember A inverse times B will give us X. And we got our A inverse to be these values. So now let's have A inverse H equals these values. So let's just write it out. Let's just draw it. So minus 1 over 20, 9 over 20, minus 1 over 4, 1 over 4, minus 1 over 4, 1 over 4, minus 7 over 20, 3 over 20, and 1 over 4. Here, let's put it here. Multiply by B. What is B? B is this matrix of our solution here, 4, 5, 6. So just watch out. So I'll have 4, 5, and 6. So it means if I multiply this, I should have my x should be equal to x1, x2, and x3. X1 is equal to, watch out, this multiplied by this multiplied by this, plus this multiplied by this, plus this multiplied by this will give you x1. So minus 1 over 20 times 4 plus 9 over 20 times 5, this times this, plus minus 1 over 4 times 6 will give me my x1. Let's do it. So we have 4 and 5. So we have minus 1 over 5 plus 4 plus 9 over 4, 3, 2, minus 3 over 2 is our x1. So if we solve this, we have our answer. So what is x2? X2 will be equal to this, which is 1 over 4 multiplied by 4, plus minus 1 over 4 multiplied by 5, plus 1 over 4 multiplied by 6. This is my x2. So this will be 1 minus 5 over 4, and then this. Okay, let's keep this as plus 6 over 4, just so we can get our solution easily. I'll say this is equals to 4 over 4 minus 5 over 4 plus 6 over 4. Then I have 4, then I have 4 minus 5 plus 6. This will be 10 minus 5, that's 5 over 4. So the value of x2 is equals to 5 over 4. We can do the same to this. Let's, from here where we have, okay, we can always solve this one subsequently so as not to waste much of our time. So that's the solution to this. What's the value of x3 now? X3 will be equal to this multiplied by 4. I hope you can see it. Let me adjust the camera so you can see it clearly. This value here multiplied by 4, that will be minus 7 over 20 times 4 plus 3 over 20 times 5 plus 1 over 4 times 6. So this will be 5 from, so we have minus 7 over 5 plus 3 over 4 plus, let's just see 1000. So you have your answer 3 over 2. If you get the calculator, you can always fix this up, and that is the value of our, and we are done with the solution. This is matrix inversion. You inverse the matrix by doing cofactor divided by determinant. Your solution you multiply by your b, your solutions, and that will give you x. So you can, so here you have your x1. Whatever you get from this solution, you write it here, and here 5 over 4, and here whatever you get from here, you write it here. Let's solve this. So this will be, let's say we are taking 20. This will be 5 in 20, that's 4. 4 times minus 1, that's minus 4. Then plus 4 in 20, that's 5. 5 times 9, that's 45. Right? Yeah, it is. And then you do the same to this. 2 in 10, that's 20, that's 2 in 20, that's 10. 10 times this, you have minus 30. So the solution will be something of 15 minus 4, that's 11 over 20. 11 over 20. This will be 5 over 4. And this will be, let's do the same to this. 25 here, 4 times 7, that's 22, we have minus 28, plus 5 times 3, that's 15, plus 30. So you have 45 minus 28. 45 minus 28 to be 17, right? Yeah, 17 over 20. So this will be 17 over 20. This is your x1, x2, x3. x1 equals 11 over 20, x2 equals 5 over 4, and x3 equals 17 over 20. And goodness, that is all about matrix inversion. Just a brief recap. Your A, you bring out your matrix from the original question. Ax equals to b, and then A inverse times b will give you x. To get your A inverse, you find the cofactor of A. Solving the cofactor of A this way, just as we have said, you can check it out. Find your determinant of A. Divide your cofactor by the determinant. That's how you get your A inverse. Multiply it by your B, and then you have x. As simple as that.